I'm Randy Chung, CEO and a co-founder of SpaceFab.us. We will provide space telescopes, space mining, and space manufacturing for the use and for the benefit of all mankind. Our first step is to build a low-cost and powerful space telescope that anyone can access through a mobile app that can be used for both astronomy and Earth observation. I started my career working on communication satellites at Hughes Aircraft. At Western Digital, I designed the world's first single-chip hard disk controller, which helped turn Western Digital into a billion-dollar storage company. I have a hardware and software background in image processing, CMOS imagers, and digital cameras.
Hi, I'm Sean League, also a co-founder of SpaceFab.us. I have a degree in astrophysics and have been in the field of astronomy and optics my entire career. I have worked as a fiber optic engineer, and I have worked on anti-missile laser systems. I've also been the VP and Director of Sales for several astronomical companies. I have started more than 5 companies, including U.S. Telescopes Incorporated.
Our first satellite is called the Waypoint. Customers can use it for high-quality astronomy when it's over Earth's night side, and for high-resolution Earth observation on the daytime side. It has 3 different cameras, where most other satellites only have a single camera. It will cost $2 million to build and to launch, about 1/3 the cost of its closest competitor. And we are already planning the next version space telescope, the Viewpoint, with 30 centimeter ground resolution, which is equivalent to the $835 million WorldView 4 satellite. By using the same advanced technologies as our Waypoint satellite, we'll be able to build and launch the Viewpoint for $10 million, about 80 times less expensive than the WorldView 4.
I'm leading the design of our Waypoint Space Telescope as Director of Spacecraft Development. Here's an engineering model of our Waypoint spacecraft. One of our key technologies is the secondary deployable system with the extendable boom, as you can see here. This allows us to launch in a compact 12U CubeSat, then extend the telescope to full length in orbit. It's amazing how much cost advantage we get by using this approach. This satellite has RGB and narrowband filters for taking beautiful pictures, as well as research-grade filters for photometry and spectroscopy. The spacecraft contains 3 types of sensors. There's an 8 megapixel image-intensified EMCCD for UV, a 48 megapixel for near IR and visible, and a 150 band hyperspectral imager. Low-speed telemetry and commands will be using the Globalstar satellite network, but this bandwidth is limited and expensive. So we'll be using a very efficient and high-speed laser communication system to communicate with our ground satellite stations and other satellites in the constellation.
We have raised a seed round of funding, which will be used to complete our space telescope design. We expect to be profitable soon after our first space telescope satellite is launched and in service. We'll use our advanced technologies that are already on the drawing board to mine metal asteroids and implement exponential space manufacturing, lowering the cost of manufacturing in space so much that it will become less expensive to manufacture objects in space than to manufacture on Earth. Our space telescope business is an essential first step toward bringing the benefits of space down to Earth to the benefit of all mankind.
Thank you, and have a great day.